Okay, so for this one we're looking for the empirical formula of an oxide containing 49.5% manganese, and what we've got here is 49.5% manganese in an oxide, which means that it's a compound containing manganese and oxygen. So if it's 49.5% manganese, the rest of it, 50.5%, must be oxygen. So what we'll do first is we assume that if it's 49.5% manganese, that if we had 100 grams of the compound, that 49.5 grams of that 100 grams would be manganese. That means the rest of it, 50.5 grams, would be oxygen. The next step is to figure out the moles of each element. So for manganese, what we'll do is we'll do grams of manganese on the bottom here to cancel that, and we'll find moles of manganese. And the relationship here is 1 mole is equal to 54.938 grams, and we can get that off the periodic chart, and that's going to come out to be 0.901 moles. And so that's for manganese. And they're going to do the same thing with oxygen, 50.5 grams of O times, and grams of O on the bottom, moles of O on top. The relationship, 1 mole of O is equal to 16.00 grams of O. Now remember, it's O and not O2, because in a compound it's no longer O2. It might react with O2 in order to form the compound, but in the compound itself it's just atomic oxygen, which is all we're interested in. So it's 1 mole of oxygen is 16.00 grams of oxygen. And that's going to be 3.16 moles of O. Yeah, but the whole point of an empirical formula here is that we want to figure out a ratio between these moles. We want to get a whole number ratio. This here doesn't mean a great deal to us right now. So what we can do in order to get a whole number is divide both of these by the smallest number of moles. So it'll be 0.901 moles divided by 0.901 moles, and that will be 1, and this is for manganese. And then we'll do the same thing for oxygen. We'll do 3.16 moles divided by 0.901 moles, and we will get 3.50, and that's for oxygen. So what we're looking at here is the mole ratio for Mn is to oxygen is going to be 1 is to 3.50. So that was the entire point of that, was to figure out a mole ratio here, but it's not a whole number yet. Now what I can do to get a whole number is I look at this and I say to myself, well, we look at the 0.5, what fraction is that closest to, what common fraction is that closest to? And 0.50 is closest to 1/2. So what I figure out is, well, that's going to be the same as saying that's 1 is to 3.5. Now if I wanted to make this a whole number, then what I would do is I'd multiply that ratio by 2, and that would be 2 is to 7. So what I'm going to end up with here is my final answer is going to be Mn2O7, because the number of moles of manganese to the number of moles of oxygen is 2 is to 7, so the formula, or of the empirical formula, ends up being Mn2O7, and you can see where each of those is going to go when we do up our table.